Good morning, ma'am. I am Jashwant Kumar and my register number is 20 BCS 0139. I choose the topic for seminar is simplified DES algorithm. It's a big algorithm. Let's see briefly about this algorithm. First, see the introduction of simplified DES. It is developed in 1996 as a teaching tool in Santa Clara University. Professor Edward Schiffer. It takes an 8-bit block plain text, a 10-bit key, and produce an 8-bit block of ciphertext. In decryption also it takes a 8-bit block of ciphertext, and the same 10 key produces the original 8-bit block of plain text. This is the SDES scheme. In this scheme we have encryption and decryption. The middle part is key generation. In the encryption we have 8-bit plain text, and in decryption also we have the 8-bit plain text. Finally it produces the same 8-bit plain text ciphertext only. First we do the process of encryption is we can find IP, later we can find FK and swap, and again FK, and finally IP inverse. It gives the 8-bit ciphertext. And in decryption also first we can find the IP inverse and FK, and again swap again FK, and finally we got IP. In the middle part there is a key generation. In the key generation first we can find a P10, and the P10 having 10-bit key. That 10-bit key we can divide it into 5, and we can do the shift operation. Its first shift is LS1. In that LS1 we can find a P8. Again we do the shift of LS2. LS2 how to find it? We can take the input of first shift LS1, then we can find LS2 shift, and after the shift we can find P8. 5 function to encrypt. IP is an initial permutation. FK is a complex 2-input function. SW is a simple permutation that swaps the 2 nibbles, and FK is the same complex 2-input function again. IP is the inverse permutation of the initial permutation. Process of encryption in detail. We can see the detail operation of encryption. First I told already, first we can find the IP, the 8-bit plain text. The 8-bit plain text we can choose the last 4 bits of IP, that is the input to EP, and we can find EP as a 8-bit plain text. That 8-bit it is divided into first 4 and last 4. The first 4 is S0 and the last 4 is S1. That S1 that S0 S1 it gives the 4-bit of P4, and now we have the 4-bit of P4. That P4 we can add it with the first 4-bit of IP. We can see the flowchart. The arrow mark will comes from the first 4-bit of IP. Then we can add a P4 and the 4-bit of IP. That 4-bit finally we have the last 4 bits, and then do the swap operation. Again we do the swap operation. The same operation of first step we can do. Again last we can take the last 4-bit of EP, then added with the key 2. Sorry, I forgot to tell in the first step we find the EP of 8-bit. That 8-bit we can add it with key 1. I forgot to tell to you. We can add it with key 1. In the second step we can add it with K2. Then the 10-bit is divided into the 4-bit is 8-bit is divided into 4-bit the same operation I tell before. S0 and S1, it gives the 4 bit of P4. The 4 bit of P4 is added with the first 4 bit of swap operation. Finally, we can find IP inverse. The initial permutation we can how to find initial permutation IP. Let us see how the process will do. Move the bits of the original character around a little. If we find the IP, definitely we have the input of 8-bit key. Okay, in the 8-bit key, it's like 2, 3, 4, 1, 5, 6, 7, 8. It's like that. So in the input we can declare the output. That's the process IP. Later we can see one example. First to see how to do the IP and EP, S0, S1. Okay, the next one is EP. EP is also having mainly the input having 4 bits, and then only we can find the output of 8-bit. It expand 4 bits into 8 bits per minute. Then wait, I will tell later. I said early one one diagram having the middle part is key generation. In the key generation, it's clearly how can we do the key generation. Let us see. First we have the 10-bit key as the input to P10. Later we can find P10, and the P10 10 bits is divided into 5 and 5. First 5 is LS1 and second 5 is the same LS1. That 5 bit we can produce we can choose the input to P8, and we got the output of P8. And next we can find LS2. The LS1 5 bit is input to the LS2, and again we have a 10 bit. The 10 bit is input to the P8. Finally we got K2. The same process only I said early. The P10 permutation, it's having mainly the 10 bit is input to the P10, and the P8 permutation is also having the input of 10 bit. After we can find the output of 8 bit. The LS1 I said already is the full form of left shift by one position. It's like we can see the PPT. First K3, K5, K2, K7, K4. It's like the first position only shifted to the last one. We can see clearly the K3 only goes to the last position of first 5 bit, and the next 5 bit the K10 only shifted to the last position of K6. And LS2, the same process of LS1, we can choose only 1 bit, but in LS2 we can choose the first 2 bit shifted to the last one. Again the 5 bits, the first 2 bit is shifted to the last one. The S0, S1, it's like a substitution boxes. We can find S0 and S1 which this matrix only. Let's see one example. Definitely everybody should understand the detailed process of simplified DES algorithm. Okay. Let's see the example of SDS algorithm. Find the ciphertext using SDS algorithm for the following information detail. I can choose my date of birth 28/2002. In this date of birth we can take ciphertext, plain text and key. No, plain text, key. The binary of 20 is 100, binary of 8 is 1000, binary of 2 is 0010. So consider first 8 bits, it's a plain text, and consider last 10 bits is a key. Okay, and I said key generation we can do the first part of SDS. In the key generation we can choose the key of 10 bits, and the first step is P10. In the right side we can draw the flow chart of key generation. The first step is we can find P10. The 10 bit of key is input to the P10. Apply permutation P10 in below. I can write the permutate of P10. Input is 1 to 10 and output is 3, 5, 2, 7, 4, 10, 1, 9, 8, 6. So we can find the output of P10 is 00, 100, 00, 10. Everybody should understand clearly. It's like we can write the third position of key is 0 and fifth position of key is 10, 0 and second position of key is 1. So we can write the 10 bits of out. We can write the 10 bit in the permanent only. And the step 2 is we can find the LS1. It's left shift by one position. Say first take the input of P10 first 5 bit and next 5 bit. We can do the LS1 operation. First 0 is go to the last position, and first again the first 0 is go to the last position. Then we can find P8. The P8 we can find the first take the input of LS1 10 bit, and we can find P8. Right side I can write the permutate of P8. Then it is clearly we can find the output of P8, and again we can do the operation of LS2. First we can do the operation of LS1. It's a left shift by one position. LS2 means a left shift by 2 position. We can move the first 2 bits to the last one. Okay, and the fifth step is P8. Again we can take the input of LS2 and we can find the output of P8. The key generation is over. Now we can do the encryption operation. In the encryption operation, the first step is IP. In the IP we can take the plain text of 8 bit, and later we can find the 8 bit of IP. In below I can write the IP permutate. It is easy to find the output of IP. In right side I draw the flow chart of encryption process. We can take the first 8 bit plain text, and we can find IP, and we can find FK, and we do the swap operation. Again we can find FK. The first FK is K1, second FK is K2, and finally 8 bit ciphertext is IP inverse. Step 2 is FK. FK means EP. Consider last 4 bits of IP. It's 40. So right side I can write the permutate of EP. It's easy to find the output of EP. So the output of EP is 8 bit. That 8 bit is divided into 4 to 4. The first 4 is S0 and the next 4 is S1. In step 3, consider the first 4 bits from step 2. So first we can take the first 4 bit of S0, 4 zeros. Now we can do some simple small process. It's like we can consider row column. The first and fourth bit is row, and second and the third bit is column. So 0 0 0 0. If 0 0 means 0th row and 0 0 means 0th column. I already said in the PPT on S0 matrix and S1 matrix, that S0 matrix we can take here. That matrix is used to calculate the S0 value. So 0th row 0th column, 0th row 0th column is 0 1. So S0 of S0 is 0 1, and the same process of S1 we can find S1 equal to 11. So the finally we can get the output of 4 bit. The 4 bit is input to P4, and find the P4 output. I can write the permutate of P4 on right side. It is easy to find the output. And the next step, the write of the first 4 bit of IP we can add it with P4. So we can finally we can got the output of 4 bit is 1001. So can write the next 4 bit is comes from second 4 bit of IP. So we can have the 8 bit of swap. The 8 bit is swapped into first so we can do the swap operation again. We can do the same process. It's like IP, EP, and first 4 bit of S0, S1, and again we find P4 and added with swap of first 4 bit. And step 6 is swap the operation of last 4 bits. Apply. Finally we can apply the IP inverse. So the final output of ciphertext is 11110110. So we can find the 8-bit ciphertext. The final answer is we can find 11110110. That's all. I think everybody got the information clearly, I think. So thank you everyone, and thank you ma'am.